Hi everybody, we are moving on to chapter 2 and this video is going to cover learning target 1 and 2. So let's just do a quick reminder. Perimeter is the distance around a shape, so it's all the sides. On a circle we call that circumference, but it's all the stuff highlighted in the green here. It's the distance around the shape. And circumference is just a special word for a circle, but it's essentially the same thing. Area is the shaded in portion of all of these shapes, so it's what it takes to fill up a two-dimensional shape. So formulas you're going to be given these formulas. So for a triangle, you're going to get your area, parallelogram, and remember a rectangle, a square, and a rhombus. They'll all be included in this. And then you have your circle, area, and circumference. These are the same thing. Remember, 2 radii are a diameter. So that's why you have 2 separate ones, and you're going to be given those. So don't be stressed out. And like I said, rectangle, rhombus, and square are all a parallelogram. So let's just do basic ones. So find the area, right? Base times height. We got this. 2 times 5, 10 centimeters squared. Area is always in squared units. For a triangle, it's 1/2 base times height. I just want to remind you that the height is always going to be perpendicular to the base, meaning that there's going to be a right angle here. You always need to stand up straight, right, when you're getting yourself measured. So you always need to have it perpendicular to the base. It won't be like this slanted height or anything like that. And then we just substitute the values in. Here, again, I wanted to talk about that height piece. The height is always perpendicular to the base, so that is the height. Now, because of that, I just highlighted a right triangle. So anytime you are missing something, don't forget about the Pythagorean theorem. That will come up a lot in this chapter, so just don't want you to forget about that. Okay, we used it a lot in the last chapter for distance formula and all of that. In this case, we'd be solving for one of the sides. I could have called A or B3. I just chose to do A. You could have used either one. C is the one that matters. It always has to be the hypotenuse. And then when you solve that, you get 4. So now that you know the height is 4, you have not 3 times 4 because we're finding the area. That was a typo on my part. I'm sorry. It should be 15 times 4. I just went with the highlighted portion. Sorry about that. So it should be 15 times 4. So this should be 60 centimeters squared. Okay, find the area. So now this isn't any of those shapes, but I can cut it into those shapes. So it kind of goes back to the box method, cutting it into stuff you know. You can do the same thing without the coordinate grid. So I'm going to cut it right there. These little dashes, that means congruent. That's how we say something is equal to something else. So this means that this is also 2 down here, that piece that shares that. Okay, and then I created a rectangle here, so I know that if this is 2, this side must be 2. And then over here I have a rectangle, and again, this means equal, so that piece is 2. So if I do 2 times 7.5, I get an area of 15 for the shaded part in pink. And then you got to be careful here. This other rectangle isn't 2 times 10, it's 2 times 8, because I'm only going to here. So I'm not including that 2, I'm just here. So 2 times 8 is 16. Add them together and you get 31. So you have 31 centimeters squared. To find the area of this shape, we're going to again label the congruent pieces, and I have a square and I have a triangle. Because it's a square, I know that this is also 8 because all 4 sides will be the same. And now I can do 8 times 8 for the pink square, and I can do 1/2 base times height for the yellow highlighted triangle and add them together. So you're just using shapes you know and adding them up. All right, same type of a problem. I know that this part here is 5, this height, because this is 5. Again, it's a rectangle. That's a property that we've known for a long time. And then I have 8 there. Again, it's a rectangle, so if this is 8, this is also 8, opposite sides. I don't know what this piece on the bottom is, but I see a right triangle here again. So again, if you're missing something that you need, think about whether or not you can use Pythagorean theorem. I'm missing a leg, so again, I'm substituting in for A, but I could have substituted in for A or B. It doesn't matter. And I get B is 12 when I solve that. So now I can do 8 times 5 for the rectangle on the left, and that's 40. And then I can do 1/2 base times height, 12 and the 5, for the triangle on the right. And I add them together, and it's 70 centimeters squared. Area and perimeter again. So now I said and perimeter. So first of all, let's label all of our sides. So that's 2, because again, those markings mean that they're equal, they're congruent. 8 comes down here, but careful because that whole piece is 8. So again, that 8 would come down there. So really that part is 6. So just be careful with that. And then we have 9 on this side for the same reason. We have 11 over here, but 2 of it's being used up, so we have 9. So for the perimeter, I just add up all of those sides. So 8 plus 2 plus 2 plus 9 plus 6 plus 11. I went here and I went around. And that's 38 centimeters. And then to find the area, I'm going to cut it into this triangle down, or excuse me, triangle, yeah, this rectangle down here and the rectangle up here. And that's 70 centimeters squared when you add them up. All right, area and perimeter again. So we're just doing lots of examples just to show you how it can work. So again, I bring the 10 down, so I can break that up to 10 and 8. So again, the 10 came down because I made it a rectangle. And then if this entire thing is 18, well, 18 minus 10 is 8. And then we have 6. Because it says perimeter, I have to find this hypotenuse. If I was just finding area, it wouldn't matter at all. So I'm using c squared because, again, I'm looking for the hypotenuse. And I get 10. And now I can add up all the sides. So just be careful when you do this. Don't double add. So 10 plus 10, this whole thing is 18. Don't do 8 plus 18 plus 10. Just don't, catch yourself on that. And then 6. So that's 44. And then I have a rectangle next to a triangle. So I'm doing 10 times 6 for the area of the rectangle on the left. And then I'm doing 1/2 base times height, 8 times 6 for the area of the triangle on the right. So left, right. I think I said them right. If not, sorry. Okay, determine the missing piece of information. So I just want to quickly work backwards from a couple of these things. You guys know how to do this. This should be, no issue whatsoever. I just want to remind you that if you have an equation, right, we can just substitute for values. So we know that if this says c equals a number times pi, because of the equation, the diameter must be 9. So if the diameter is 9, well, again, if you just need a reminder, the diameter is the full length across. So if you have a circle, the diameter is that green line. Therefore, a radius must be half of that. So that would be 4.5. Over here, if the radius is 3, again, if I use that c pi d formula, I know that the diameter, if the radius is 3, the diameter has to be 6. So 6 pi is the circumference. Just wanted to throw that stuff at you. All right, let's do general circumference. So again, it's pi times the diameter. D stands for diameter. So for something like number 5, that's it, 4 pi. That's all you got to do. If I ask for it rounded, you would then approximate that value in your calculator, but you don't have to. In number 6, I have to double the radius, so 6, and it's that easy. In number 7 and number 8, this kind of leads into what we want to do here. I want the circumference of 7, or the perimeter, whatever you want to call it, and 8. So if you notice, that's half a circle. So I can do half of the circumference formula, so 1/2 pi d, that would cover the green part. But then we have to account for this 8, so that's why the plus 8 is there. So we substitute those values in. The diameter is 8, and there we go, 4 pi plus 8. Again, that would be fine, because if I don't tell you how to round, that is a perfect, wonderful, beautiful answer. Over here, I'm hoping you realize that this is 3/4 of a circle. If not, what I'm about to do next will help you see that. But we have 3/4 pi d, and then I'm adding 4 because this radius is 4, so this radius is also 4. And again, I want the circumference of the perimeter around the entire thing, so I have to account for both of those parts. And then again, 6 pi plus 8 would be an answer unless I tell you to approximate. Now let's do area. So area is pi r squared. So we're just going to substitute the values in. Don't forget, if you're given the diameter, the radius is half of that. So 2 squared is 4, 4 pi is your answer. 3 squared is 9, 9 pi is your answer. It's that easy. Now, to find the area of something like this, well, number 11 isn't too bad. It's half of a circle. So I'm just going to do half pi r squared. Again, radius is 4 because the diameter is 8, and I get 8 pi. In number 12, I have to do 1/2. Now, if you notice, this 8 is going to also be here. So my radius of this half circle is 4. So I'm doing half a circle plus the rectangle on the bottom. So that would be 8 pi plus 16 when you simplify it. Okay. Now, to do a sector, okay, what you want to realize is that it's part of a circle. Now, in the other 2 examples, I gave you like a half a circle or 3/4 of a circle. It was a little bit easier to see. But to find the area of a sector, it's something out of 360 degrees. So when I say this sector, I'm talking about the highlighted portion with the darker black lines. this part in here, that's called a sector of a circle. So if I want to find the area of that sector, I don't want 360 degrees out of 360 degrees. I'm only wanting 195 degrees out of that. So then I use my area formula, and I simply multiply it. Now this is called a central angle. So this degree that they give you, that's just fancy term, central angle. So basically you just do the area formula and then you multiply it the fraction of the circle you want. So that would be 195 degrees out of 360 degrees. And that reduces down very nicely. Now, I circled this part because this would be all I was typing into the calculator, and that would be a nice, beautiful, exact answer. Again, if I told you to round, you would then use the pi button on your calculator, and you would approximate the value. So again, find the area of the sector. So we're going to do pi r squared, so 6 is the radius, and then I want 210 out of 360 degrees. And I get 21 pi. One more example. Pi r squared, you get 13 squared, 210 out of 360, boom. It's not pretty, it's not a pretty number, right? But that is the answer. And here we go again, pi r squared, 45 out of 360. It's always the radius for pi r squared, and then it's the angle out of 360. Now we're going to do the length of the arc. So I'm not asking for you to find the area, I'm asking for just this length. So what I'm highlighting right now is the length. That's part of the circumference of the circle. So to find the length of an arc, it's going to be very similar to what we just did, but instead of doing the area, I'm going to use circumference, but it's going to be circumference times that central angle over 360. So in this case, it's going to be pi times 6, because if the radius is 3, the diameter is 6, and then 120 out of 360 is what I want, so it's 2 pi. Over here, again, it's the circumference, so pi d times the area, or excuse me, the angle that I'm looking for out of 360. So 26 is the diameter, 150 out of 360, reduce it, and there you go. That's it. I'm assuming sector area and arc length were the new pieces. We'll go over it some more in class. Have a great day.